A particle moves in a straight line so that its displacement from a fixed point O at time t second is x meter. Alright, now imagine that there's a car and this is the fixed point O, which is the house. Straight line away from the origin, and displacement is going to be equal to x equal to. Now, question A, find the time when the particle changes direction. So imagine that this car, after traveling some time, forgot something at home and changed direction back to O. So we know whenever something changes direction, the velocity will stop, where the velocity will be equal to 0. Because when the car need to change direction, the car will stop for a moment and then only they can change direction. The V will be 0. This is the T is 0. Now, we know that this is chapter kinematics. So whenever you have a displacement, velocity and acceleration, to go from displacement to velocity, you need to differentiate it. So now our unknown here is x and t. So it's going to be dx over dt. And to go from here to here, you have to differentiate it. If you want to go backward, we need to integrate v from acceleration to velocity. We integrate acceleration. So now, what we were given here is displacement, which is this one. So we wanted to find the velocity, so we will need to differentiate this. Let's differentiate that, so it's going to be dx over dt. Now, this is power rule. 3 bring in front, and then power minus 1. So 3t power 2 plus 2 bring in front, 2t minus 1 minus 1. Okay, now since we know that this is going to be equal to velocity, and we know that when it changes direction, velocity is going to be 0, we can just do 3t power 2 plus 2t minus 1 equal to 0. Now from here on, we just need to factor out and then find our t. 3t, t minus 1 and plus 1. Solving t, 3t minus 1 equal to 0, t will be 1 over 3. For that side, t will be equal to negative 1. In this case, we know t is time and there's no time in negative. We will reject this. When the velocity is changing, that is when the time is equal to 1 over 3. Let's compare with the marking scheme. When I know the relation between the displacement and the velocity, and when I factor out and find the t, I'm going to get another mark, and when I get to my final answer, which is this one, I'm going to get another mark. So this is 3-mark question. Moving on, show that the particle is moving towards O when t is equal to 0. When t is equal to 0, x equal to t square plus t2 minus t plus 8. When t is equal to 0, all of this will be 0. So we know that it has been already traveling 8 meter. We know that from t0 to origin O, which is home, that's going to be 8 meter. It's going to be 3t square plus 2t minus 1. When t is equal to 0, our velocity will be 0, 0, negative 1. Our velocity is negative 1. Since velocity is a vector, this negative 1 is showing that it's moving towards the O. Let's make a conclusion. Since x is positive 8 and v is equal to negative 1, it is moving in opposite way. Let's compare with the marking scheme. This is 3-mark question. When we understand that at t equal to 0, it already have traveled 8 meter, and because of that, when the velocity is negative, it's indicating that it's moving the opposite way, or we can also say it's moving towards O. Our conclusion is going to give us 1 mark. Find the total distance traveled by particle during the first 2 seconds. Before we start, there's 2 different terms that you need to understand, the differences between distance and displacement. Distance is a scalar and displacement is a vector. Vector means direction is important. Now, since we want to find distance, this car have been moving and then the car has been making a U-turn. We cannot ignore the U-turn. the car will change direction. So let's split the journey. So this is the start, which is t0, to t1/3. We wanted to find until the first 2 seconds. Let's calculate the position. So it's going to start from here, which is t equal to 0. Let's substitute t value to find x. When t is equal to 0, the x will be 0, 0, 0. The x will be 8. And x is in meter. From here to here, we know it's already traveled 8 meter. Okay, and then let's substitute t equal to 1/3 to find the distance over there, equal to 1/3. So x is going to be 1/3 over 3 plus 1/3 power 2 minus 1/3 plus 8, 211/27. And because we wanted to know until 2 seconds, let's find t equal to 2 seconds. So x is just going to be 2 power 3 plus 2 power 2 minus 2 plus 8. Now, please remember, we want to find total distance travel. This is the starting point, so we need to find this 0 to 3, and then we need to add 0 to 2. But you need to know that t equal to 0, you already have 8 meter. So what you need to do is, to find this part right here, we need to minus 8 meter. From t0 to t equal to 1/3, 8 minus 211/27, 5/27. Let's do the second part right here, where we know that this total is going to be 18. From t equal to 1/3 to t equal to 2, 18 minus 211/27, 275/27. To get the total distance, if this is 5/27 and this is 275/27, we just need to add this up. Total distance approximately 10.37 or 10.4 meter. This is 4-mark question. The first part is that when we understand that t 1/3, that is going to be equal to 211/27. So that is over here, t 1/3, it's equal to 211/27. And then when we understand that whatever that we have, we need to minus 8. 18 need to minus 211/27. To get the total distance, we just add them up, 10.4 or 10.37. So 4 marks here. Okay, there's another alternative method. Let's visualize graph velocity versus time. Since we know our velocity is equal to 3t squared plus 2t minus 1, and our t is from -1 to t equal to 1/3, let's plot this quadratic graph. -1, and here is 1/3. The properties of velocity time graph is that the total distance is the area under the curve. We want to find the total distance at time 0 until 2. So we need to find the area under 0 to 1/3 and then add that from 1/3 to 2. Let's label the first area as A, and this area we're going to integrate it from 0 to 1/3. And the velocity equation is 3t power 2 plus 2t minus 1. Because we want to find the total distance, we will add the second area. Let's label the second area as B. To integrate B area, the lower limit will be 1/3 to 2. And we're going to use the same velocity. Since this is paper calculator, let's use our integral function in the calculator, starting with the limit of 0 to the limit of 1/3. And I'm going to input my velocity 3 alpha x as my unknown, power 2 plus 2 alpha x and then just make it equal. Just hit equal button, and then that is my answer. I'm going to make it to fraction to make it easier to see and write. So it's going to be negative 5 over 27. We're going to ignore the negative. Negative means it's just at the bottom of the axis. But because we want to find total distance, we're going to ignore it. Now, let's input the second part, which is b. Here, we will just put the same thing. It's just the limit is going to be different, starting from 1 over 3 to, instead of 3, we change it to 2. And just hit the answer button. And we're going to get 275 over 27. Since what we want is the total distance, we're going to add the two areas together. And you can see our final answer is the same as the first method, which is 10.4. It's up to you to choose. In this question, you need to know how to get from displacement to velocity. And what does change direction means? It means that velocity is going to be equal to 0 and distance is not the same as displacement. For a distance, you always need to add absolute path. For example, even though it goes back and the direction is negative, we do not include the negative sign because it's a distance.